Hey everybody, welcome back to the Print3D channel. We've got something really cool for you guys today. This is the MakerBox monthly subscription service, and this is the MakeBox, and we're going to unbox it and check out what's inside, so stick around. Hey everybody, welcome back, and thank you for joining me here on the Print3D channel. Recently, Shea Street, and I'll put his information down in the description, put together a little care package for all those who couldn't attend one of the recent maker fairs. And of course, he did a little bit of a lottery and a nomination system, and my name came up, and of course, I was very humble to receive one of these packages. And part of that deal is the MakerBox company was sending out samples of their May subscription service to some of those recipients, or all of those recipients. And my box came, and I wanted to unbox it with you guys and share what's inside. Huge shout out to MakerBox for sending this over for me to review on the channel. And of course, a major shout out to Shea Street for organizing the little care packages that are going out to all the people who couldn't attend one of the recent maker fairs. Of course, we aren't compensated for our opinion. This was sent to the channel for free, for review, and we're going to find out what's inside. Now, if you're familiar with the channel, you know I've gotten a few of these subscription services in the past. And all the way back at the beginning of the channel, we actually got one of those subscription service boxes. And one of the tools that came with it, I'm actually using to this day. So I really like these boxes because they come with some really cool stuff. Some samples of filament, some stickers, which I can add to my sticker wall, which you probably don't see behind me because we're right now in the new shop. And it's going to change every time you see a video. There might be something different behind me. But for now, this is the setup for now. And you also get some sample filaments. And I haven't had a chance to unbox it because I wanted to do this properly, plus we were moving some stuff around to make the new shop. So we're going to dig into the MakeBox and we're going to print some samples, and at the end I'll show you all the prints and we'll talk about exactly how cool these subscription services are. There's quite a few of them out there. This is a long-lasting one. I know there's quite a few content creators who put out reviews of these every single month, and I've seen quite a few reviews and they really enjoy the filament, and I was really excited to get one of these so I can check out that filament that everybody's talking about and most likely buy some of those because they're samples of filament that they carry. So let's go ahead and get inside the box and see what's inside. I believe there's just a piece of tape on this side, and I have my trusty X-Acto knife, and I have a secondary camera set over here so we can see what's inside as we open it. And like I said, I've gotten many subscription services in the past, even some for non-3D printing stuff, and I really enjoy them because they're really cool, and you get to try out some really cool stuff before you buy it, plus you get cool stuff inside the box. So let's go ahead and open it up and see what's inside. So the first thing, as always, everybody loves their candy in the 3D printing community, so we have some Sweet Tarts. These are Sweet Tarts Mini Chews. These are going to be yummy while I'm working. There's a advertisement business card here for ERF 2019. Get your tickets today. That should be a really, really fun maker fair. I've been wanting to go for this for some time now. We have a sample of the Gecko plate, or Gecko Tech's Gecko print surface. This is the Easy Stick Hot, so I'm guessing this is for heated build plates. It's a nice little sample. Be good for small based printers or just to try it out on your larger printer and just print in the area before you buy a full sheet of Gecko Tech and install it. So that's really cool. And of course, there's a little free sample advertisement for Gecko Tech. And the next we have a little tiny sticker, and it looks like it's a picture of a dog. I'm not sure whose dog that is, but very cool. I'll add that to the sticker wall. And a little card here, I guess it's a sticker. It says, "Shift happens," even to Jim Carter. So shout out to Jim Carter in the box with his cool shifty benchy. It's very shifty. And we have an advertisement for the MakerBox loyalty program. Starting in January, we'll be sending out rewards for consecutive membership months. So that's a really great bonus for those who are already subscribed to this, or if you're going to subscribe. At 8 months, you'll get a limited edition filament sample in your box. And at 16 months, you'll get a certificate for a free MakerBox t-shirt. Pretty cool. So they're doing a loyalty rewards program, which is something I don't think the other ones are doing at this time. So the first sample we see is nylon 230. It is from Taulman, and this has a print temperature of 228 to 235. Bed temperature is room temperature, so I can print this on the G-Max because I have the sanded acrylic bed. And it doesn't say anything about anything else on here. It just has a little bit used glue stick or the enclosed Gecko Tech sample. So this looks like some natural. Yeah, nylon natural. It's a nice sample. Seems to be a lot on here. You guys can see that. And here's the information. It looks a little faded, but still readable. That's our first sample. The next sample is what we have is architectural clay from Treed. And it says the hot end temperature is 220 to 240, and the bed temperature is 85 to 115 C. I have a heated bed, and I have other printers that have heated beds, and the speed 60 to 70. It says filament is mixed with a clay powder for prints with an excellent surface finish. And it's got a really, it's definitely clay colored, and hopefully the other camera will pick up the color of how cool this looks. Architectural clay. I'm definitely going to have to try this out. I'm very curious about that. And you need a heated bed, and like I said, I have printers with heated beds. 3D Fuel, there's a very familiar name there. This is their glass-filled PLA in industrial gray, has a hot end temperature of 190 to 210, a bed temperature of none to 60 C, speeds 40 to 100, hardened nozzle advised. And the info on this says it's a glass-filled PLA. Yeah, glass-filled PLA 3D printer filament is a first-of-its-kind engineering-grade filament that can be used on any machine capable of printing standard PLA, of course with a hardened nozzle. Glass-filled PLA filament offers similar benefits of standard PLA, such as very low warp, low odor, and no special extruder or heated bed needed, except for that hardened nozzle, which it noted at the top. But the power of its composite makeup allows it to be stronger, tougher, and more flexible. Interesting. Never heard of it. So I'm guessing like a fiberglass style. 3D Fuel. Awesome. That'll be a fun one to check out and print with. Hopefully you guys are seeing these in focus. And another sample, we have PLA Plus U Diamond from Carbodeon. And it says a hot end temperature of 220 to 250, bed temperature of none to 50 C, and a speed of up to 500 millimeters per second. That's pretty fast. 100% cooling, no other information. And this is just a diamond enhanced 3D printing filament. It contains functionalized nanodiamond particles. Hardened nozzle for sure. Nanodiamonds are spherical and act as a lubricant in the filament extrusion, causing no increase in nozzle wear. I'm still going to keep my hardened nozzle. The enhanced thermal conductivity of the material enables print speeds of up to 500 millimeters per second. The diamond particles also reinforce the polymer structure, improving the stiffness, strength, and adhesion between printed layers. That's interesting. Definitely going to try that out and check out that bonding between layers, because that is a very common problem in 3D printing, is layer bonding issues. The filament is suitable for consumer grade and professional grade FDM FFF printers. Combination of stiffness, strength, wear resistance, and unique thermal features make it the #1 PLA for functional mechanical prints. It has, you can see, there is a weird look to it. It's almost pearlescent. It's very interesting. Yeah, it's definitely like a pearlescent look to it. And here's the front, so you guys can see it. And I'll get some close-ups and prints after we finish going through the box here, and we'll fire up the G-Max for the stuff we can print with a heated bed. And I think I have another printer behind me that has a heated bed. And now we have some wood PLA from Tianse, made in China. It's a hot end temperature of 200 to 220, bed temperature of room to 50, speed not provided, cooling yes, and it says either a 0.5 or a larger nozzle is advised. Of course, that is something that's very much in talk right now about using wood fill filaments. And because they come from different composite PLA plastics and different wood sources and the types of wood and how it's actually intermixed within the PLA, depending on the kind of PLA, all kinds of factors involved. So this will be a fun one to test because I love that kind of PLA, wood enhanced. I have a lot of prints that I've been testing with, adding some stain to them in the future for a big video that I want to do, but that's neither here nor there. And it just says wood PLA composite with 25 to 30% wood added. It doesn't tell you what kind of wood, if it's shavings or powder. You can definitely see a texture on there. It's pretty smooth through the plastic, but I can definitely see a texture. My concern with any kind of filled filaments is air bubbles. Air exists within wood, even in the smallest nanoparticle, and you don't want any kind of air bubbles running through your extruder. It can cause popping, which could cause some sort of jam on your extruder nozzle. But we're going to give this a try. I'm always curious to try new filaments. We've got quite the pile here. So here is the front. And you can get a quick look at the filament itself. And I'll take these out of the bag and get some really great close-ups we'll add to the end of the video. And the last thing, of course, is a MakerBox button, which I will add to my coat when I go to Maker Fairs. So that is everything that's in the box. There's some information here on the inside. Save more on full spools at extrudingknowledge.com/codes. Refer 3 friends to earn a free box. Ooh, that's pretty cool. And then it says printedsolid.com on the inside because this is through Printed Solid. So anyway, that is everything that is in the MakerBox subscription service box. We've got 1, 2, 3, 4, 5 samples of filament. 5 really interesting, I've never seen before types of filament. I've used nylon in the past, I've used wood PLA, but not at that high of a fill, to my knowledge. Glass-filled, architectural clay, and this PLA plus U diamond. I'm very curious about this filament. So we're going to pull these out of the box. We're going to get some close-ups of them. We're going to do my standard filament test, and if you're unfamiliar with the channel, what we do on all filament that comes into the channel for testing or review is I do a series of tests before I even put it in the printer. And that includes the bend test, the clip test, and I will be checking the diameter on all of this filament to make sure it is accurately 1.75 within a 0.2 to 0.02 to 0.05 accuracy is the preferred number. So we'll check all that stuff out. We'll get some prints going. And at the end, I'll give you guys my opinion. I can tell you right off the bat, I love subscription boxes, so it's going to be a very positive considering I have 5 samples of filament. I have a little piece of Gecko Tech to try out, which I want to get a full sheet for my G-Max. I've always wanted to have some of this. It's supposed to be some really great material. We do have some candy to nosh on while we're doing our test prints. I'll let you know how these Sweet Tarts mini chews taste. Make sure they have all kinds of sugar in them because I don't like artificial flavoring. We got the cool little advertisement for this year's Earth 2019. Hopefully I'll be able to attend that one this year. And of course, a little shout out to Jim Carter with Shift Happens and a sticker and their loyalty program announcement. So let's go ahead and pop open the packages. Let's start printing and let's get some samples going and we'll have a nice little montage. And then I'll come back and probably be tomorrow because I want a chance to use up every little bit of filament that they gave us. I don't want to have any full bags when I come back to finish off this little review of the monthly MakerBox from MakerBox. So I'll talk to you guys in a little bit. Let's go ahead and start printing. Okay, so we've wrapped up our testing of the filaments that were included in this month's MakerBox, and I can tell you right now, I felt like a mad scientist printing with this stuff. There are so many different variables and settings and build plate, adhesion methods, or heat, whether you need to be high heat or low heat, but we'll talk about that as we go through each of the different filaments. The first filament we started to print with was the PLA Plus U Diamond. Now, this is some unique properties filament. According to the package, and I'm going to dump out everything and you're going to see the results of some of the prints right off the bat here. This filament boasts being a nanoparticle, functionalized nanodiamond particles, which is supposed to increase the lubrication of the filament through the hot end and make the filament stronger. Now, let's talk about the temperature settings. Now, for every model that we printed two models that are exactly the same, and that would be the Cali Cat and the Rose Twist Vase. And then I printed items that I thought would be complementary to the filament types, so some are functional and some are decorative. But there's going to be a consistency across the board because we printed out a Cali Cat and a Rose Twist Vase because those are my standard test models when I print any filament here on the channel. And all the models with all the filaments were printed on the G-Max 1.5 XT Plus using different types of build plates and filament adhesion methods, but we'll get into that as we go. So back to the PLA Plus U Diamond. Again, this is supposed to be a easy to print with super strong filament because of these functionalized nanodiamond particles. And I had a lot of difficulty getting started printing. The first thing I print, as always, with every single roll of filament I get is a Cali Cat. Now, this is a super fast print. It features a lot of features. It features a lot of features on the model that would be important when you're testing filaments, I guess. Every filament is different. If you're going to test a filament, you usually go by the settings that are on the package and then dial it into your own liking and then print out a model and see how it looks. So for me, this Cali Cat has a lot of features that I would find on other models, like very fine detail, overhangs, and areas where it needs to bridge and it needs to cross between gaps to check for stringing. And I don't have to print out a whole bunch of different models. Everything is in one place. So there are other test models out there you can print, and I know people like to print the retraction test and a temperature tower, but when you get samples of filament, you kind of just want to see what they look like. You go by the settings on the package and you kind of wing it from there. So instead of doing a bunch of test models, I printed out functional and models you can see the print quality and the finish and such like that. So for this PLA Plus U Diamond, I had some trouble printing. Now, the first thing I printed on was the sanded acrylic bed, which is the normal print surface I use on the G-Max 1.5 XT Plus for any type of filament. I have had great success with all types of filament. This stuck to the bed. It stuck so hard that it actually broke off. Now, I don't know if that's layer adhesion or if it's just because it stuck to the bed so well. I haven't tested this to see how strong the layers are because that's one of the things that it boasts, is it's a stronger material to use. So let's go ahead and see if we can break. Don't think it's going to be breaking. And I printed this at the medium temperature setting, which would be between 220 and 250. So this was printed at 235 on a cold bed, acrylic bed. And I printed everything in all the models at 40 millimeters per second, with the first layer printing at half speed. Now, the variables will be different as far as like top and bottom layers and perimeters and infill, but we'll talk about that for each bag of filament that we tested with. But for this, we printed this with 3 perimeters, 3 top layers, 3 bottom layers, and 20% infill at 40 millimeters per second at 235 degrees on the hot end on the cold acrylic bed, and it stuck to the bed too well. Now, it did break at the layers and not at the bottom where I normally suspect it would break. So I thought for sure that it would be a layer adhesion problem, but it's not at that temperature on a cold bed. But it was sticking too well, and I didn't want to ruin my sanded acrylic bed. So I quickly removed the sanded acrylic and installed the glass bed, which has a heated module included with it. And I used straight on the glass bed printing. Now, I couldn't get the models to stick to the bed. So I ended up applying the build tack to it, and I still did not get it to stick properly. It would start to peel up pretty quickly. So I finally added the magic of Magigoo. And Magigoo and build tack make a super bond surface that's super easy to print on. So pretty much everything after that, I was starting to use Magigoo and build tack as a combination with or without heat. So even on a cold bed, Magigoo does help. So I printed out the, as you can see here, it's already broken. I printed out the Rose Twist Vase next because, in my opinion, the rest of the model had printed out well, and as you can see, seems to be pretty strong. There seems to be pretty good layer bonding, but it bonded so well to the acrylic that I broke the model taking it off. That was my thought. I printed out this at the same temperature, 235 degrees. This is the rose twist vase. And I printed this out at my usual vase mode settings, which are 40 millimeters per second with 3 bottom layers. Or actually, you know what, 2 bottom layers on this one, because I have a limited amount of filament. And while the print itself turned out really good, when I went to remove it from the print bed, it still stuck really well to the sanded acrylic. It was at this point that I changed it over to the glass bed, and then I started having issues. And then I put on the Build Tack, and then I started using the Magic Goo and Build Tack combination. Sorry, correct on that, on my process to getting to this point. So after the Cali Cat stuck so well, and after the Rose Twist Vase stuck so well and broke off at the bottom, and there's actually a piece of filament that stuck to the bed that required a little bit of effort, the acrylic, that's when I made the change. But for this print, this particular print, when I pulled it off the print bed, not only did the bottom break, but the top part broke off, and I can feel like it feels strong, but that gave me the indication. Well, yeah, there we go. And I didn't use any effort to do that. There's really not strong layer adhesion. I mean, this is a single perimeter out of a 0.5 millimeter nozzle, printed at 235C on the hot end. So I don't expect it to be strong, but I expect it to be a little bit stronger than that, especially on the bottom, even though it's stuck so well on the sanded acrylic. So the next thing I wanted to print was to move on to a functional item for the testing, which in this case was the axle for the OpenRC F1 project. Now, for this, I thought it would be really cool for that car to have a diamond axle, something that's super, super strong. Again, printed at 235C, but this time we've moved to a non-heated bed with Magic Goo and Build Tack applied, 235C on the hot end, and printing at 40 millimeters per second. So for this, we did our standard layer height, which is the standard layer height I printed most of these models at, which is a 0.24 millimeter layer height. And it actually turned out really good. There is a little bit of warping on this end of it here, so I don't know if it's going to make an effective axle, but the idea is cool. A diamond axle, printed at 235C. Make note of that. And it feels really, really strong, and I think it'll do a really good job. But again, I got a little bit of lift, a little bit of warping on the ends. And sometimes that happens with small footprints like this. But I've printed this before and didn't have that problem. So I thought I should print some more functional parts. So I went into my archives and I found, this part's already broken, I found the Ultimaker clone that's available on Thingiverse, which I've always wanted to print, and I thought this particular filament, PLA plus U diamond, would make an awesome printer parts. But I wanted to do some further testing. I wanted to drop the temperature down. So 235C for PLA is a little bit hot. I mean, it's PLA, it doesn't need to be that hot. And I can't see how the diamond would affect the quality of the PLA print temperature if it's supposed to increase the print speed. So we dropped it down to 220 for this print. Took it off the print. It looked really great. We did 2 perimeters, 2 top layers, 2 bottom layers, 25% infill at 40 millimeters per second with a half speed on the first layer. And the print turned out great. I took it off the print bed, and then I was able to easily break it in half. And I can see that there's no layer adhesion. So I don't think dropping the temperature down was a good idea. So I went back up to 235, same perimeter, same parameters for the other part of this, and this is one of the corner brackets for the exact same Ultimaker clone. And this feels pretty strong. Now I'm going to try and break this on camera, and I probably should use some gloves or something, but I don't think I could break this. I don't really like printing at that high of a temperature though. So there is a give and take with this particular filament. If you want to utilize the strength, you have to print really hot. And I would suggest printing on a surface like a PEI or maybe a Gecko-Tech sheet, which a sample was included, which I did not get to test. Sorry about that. You would need a better print surface to print on because this requires some special bed adhesion. I think those nanoparticles not only lubricate the filament, but they also lubricate that first layer and make it a little bit difficult to stick. So these were printed with, these printer parts were printed on the Build Tack with the Magic Goo, and these are printed on the sanded acrylic. These stuck too well. These stuck okay. This didn't stick so good on the edges. So a lot of parameter changes just to get the PLA plus U diamond to print. Overall, I think it's a strong filament, but I can't tell. I need more of it, obviously. 50 grams isn't enough. It's very cool to test with this type of filament, and this is enough for me to do this much testing to see that it could possibly be a strong filament, but I don't like that dropping it down to 220, which is like a high-end temperature for PLA anyway, gave me terrible layer adhesion. So overall, I think this is a really cool filament. I definitely would want to experiment with it some more, but the print settings are a little bit high for me for printing with just general PLA. Even with a substance or material added to the filament or to the plastic that's supposed to help increase print speed and rigidity and strength, and I don't see that illustrated here. So I'm at a 50-50 on this. I think it might work as a strength enhancer, but the difficulty to make it print properly kind of washes out that. So in my opinion, cool idea, but I think this requires further testing. I would definitely need a whole roll of this, and I would definitely require some strength testing apparatuses to really see that diamond, one of the hardest surfaces known to man, is helping plastic become stronger at a nanoparticle level. So cool filament. Wish I had some more of it to test with, but I'm kind of on the fence if it's strong enough. Don't like the high temperatures and the variables, and of course, I couldn't get it to print on the sanded acrylic. So it's cool, but I don't think I'd want to print with this as a machine material unless I did like a whole roll of testing. And I'd have to do a lot of testing because that 15-degree temperature difference way up into the high end for PLA at 235 is out of my comfort zone for printing this kind of plastic. So let me put all these items back in the plastic bag and we'll move on to the next bag of filament. Diamonds were definitely not my printer's best friend. Okay, so once we were wrapped up with the PLA plus U diamond, the next filament I printed with was the PLA plus glass, or glass-filled PLA. Now there's some information about the filament, but it doesn't tell you what percentage of glass or what kind of glass is added to it. But the basics are it's 190 to 210 C on the hot end, bed temperature is none to 60 C, speed 40 to 100 millimeters per second, and it's advising that you use a hardened nozzle. But it also says you don't need a special extruder or a heated bed needed. And it says that it makes it a lot stronger, tougher, and more flexible, which we'll talk about that in a second. But the filament itself was actually pretty easy to print with. Now let me dump everything out so you guys can see everything. And it'll be gray on gray, so I'll bring everything up to the camera. So basically, we started with the Cali Cat, which is what I always print with, as you know. And the first print, printing in this at 195, because I always add a few degrees, because my GMAX drifts temperature about 2-3 degrees on the hot end during a print. So I always add 5. And using the build tech and, of course, magic of Magigoo, we were able to get a successful print on the first try of the Cali Cat. Now, the print quality is excellent on this. It has a certain glint to it, a certain kind of sparkle to it because of the glass added to it. And it does feel real strong. It feels real dense. Like there is some density and strength to the filament, or to the final model that's printed. It has a rough surface going in, and you can see the glint on the filament or the sparkle of the glass. But I don't know what kind of glass and what percentage, and I don't know if it's, you know, what this adds to the properties of the filament. This is by 3D Fuel. They're a popular company. The links for all these filaments plus MakerBox is down in the description. You can look it up yourself and see about the information about this particular filament. But I think this is really cool. I think the Cali Cat turned out great. Again, my standard settings for printing one of these is 3 top layers, 3 bottom layers, 3 perimeters with 20% infill at 40 millimeters per second, half speed on the first layer. So this printed out perfectly at 195 C on a cold bed using Magigoo and Build Tack. I didn't have any problems. It came off the print bed easily. The bottom layer looks good. The surface quality. I looked at it through the macro lens. I could see some deviation in the filament, some minor air bubblage, but that always happens when you add something to a filament. You're going to get the added caution of, or added issue of possibly having micro air bubbles in there, which you'll hear as pops while you're printing. But this didn't have that issue. It looked pretty good. I felt it was time to move on to the rose twist vase, and it turned out spectacular. It has that same surface finish. It's got a bit of a glint to it. I do like this surface color to it. The gray is very deep, rich gray color to it, and it feels pretty strong. I mean, I probably could crush this, but I don't want to. I'm not going to crush this on camera or anything like that, because I want to use this as I'm looking for something to build functional parts that are strong, printed with a base PLA, at a nice low temperature without requiring any special print speeds or print bed or heated or anything like that. I just want to be able to print a super strong additive in PLA filament. And I think this is it. I really like the way this turned out. I like the color. Like I said, I like the glint to it, and it does feel pretty strong. I mean, I'm squeezing this pretty hard, and I don't think I could break it from that, but it's like an egg at this side. You don't really be able to break it. I was able to easily break the diamond one that way, but I don't think I can break this one. So moving forward, the prints look great. I thought everything turned out awesome. I wanted to print some more functional prints out of this type of material. So I printed the main drive gear, or pinion gear and drive gear for the OpenRC F1 car in the glass-filled PLA. I figured a combination of the diamond axle and glass-filled PLA, we have some really cool strength and added durability to these materials than standard PLA. And these parts turned out great. I didn't have any problems. Again, we did 3 perimeters, 3 top layers, 3 bottom layers, 25% infill on these because these are functional parts. And we also printed these out at 40 millimeters per second with a half speed at the first layer. So printing these at 195C, cold bed, Magic Goo build tack, no problems whatsoever. Prints look great. They still have that cool glint to them. I really like the surface finish. The gears are nice and sharp. I definitely think these are going to be better than standard PLA in that particular functional area. So the next thing I printed out, and I do have a sizable amount of filament left. I said I was going to use as much as possible, but for this, I'm going to save this last of it because I have some more parts for the OpenRC that I want to print in this particular filament because I'm happy with the results. So the last thing I printed out as a sample is this cool cat on the moon. I guess this would be wall hanging. I guess you could print this smaller and make it an earring or a brooch or a pendant, but it's more of a wall hanging. And I printed this out at a 0.16 millimeter layer height with 3 top layers, 3 bottom layers, and 20% infill. And I dropped down the print speed to 35 millimeters per second because it's got some nice detail to it. Not a lot, but enough that I wanted it to be a nice smooth print. And I probably didn't have to do that. The print itself turned out amazing. It really looks cool. I love the glint on it. It's got a nice surface finish. Printed no problem, didn't have any warping, came right off the print bed using the Magic Goo build tack without an issue. So overall, the glass-filled PLA from 3D Fuel is a really unique filament. I definitely will do some more testing with what I have left, and I'm definitely going to order some more. I was able to get a successful print at the low end of the print temperatures at 195C on the hot end with no heated bed, just using build tack and Magic Goo combination, and it turned out great. I really love this filament. It's got a really cool surface finish. It was super easy to print with. The prints themselves, they look really good. There was no blobs, no globs, no layer shifts, no layer skips. I think even the temperature could drop down a few degrees because you can see on the Cali Cat near his chin, there's a little curl up on those corners. That's probably from a little excessive heat. But again, having some success on the settings printed on the package on the first go is the kind of filament testing I like to do. I don't like to struggle too much or have to do too many variables. I like to be able to read the package and print and see what kind of surface finish and surface quality and printability they are. And then I can dial in settings like stringing and other things like that later on. But they suggest a temperature, I use a temperature. So I'm really happy with this really cool glass-filled PLA. It's a really cool filament. Like I said, the texture of the filament is kind of rough, but you can see the glint in it. And during the usual testing of all the filaments, which I'll be showing you as we're talking here as far as my bend test, my clip test, and the diameter check on everything, all these filaments checked out pretty good. I'm pretty happy with the results. This filament especially. I'm definitely going to order a full roll of this 3D Fuel. I'm going to see if they have some other colors than gray, because while this gray is cool, I think this would look cool in other colors. If not, maybe I can suggest they make them. But I love this filament. It's really fun to print with. I've got enough sample here to keep printing some more items. And like I said, those will be for the OpenRC F1 car that I'm putting together. Oop, I gave a little bit away there. For more parts for an OpenRC F1 car. And I probably will get a whole roll so I can use it to print out parts for a printer, because I think this is strong enough and it has all the characteristics that I like, and plus that little bit of glint gives it a little bit of flair at the end. So if you're looking for some unique filament to print with that has a little bit extra durability, a little bit more rigidity to it, prints at basic PLA settings without any problems on a cold bed, I definitely recommend the glass-filled PLA. It's definitely something I'll definitely experiment with and I'll use a lot of. So this was a cool addition to the MakerBox set of filaments that they sent us, and I'm really excited to print some more with that. So after that, I moved on to the wood PLA that was included. Now, I've printed with other wood-enhanced PLAs before, but they didn't say exactly how much wood is in them, and that has always been a mystery. I know there are some brands out there that do tell you how much wood is actually added, but this particular brand from Tianse, it actually says wood PLA composite with 25 to 35% wood added. It tells you right there on there. So I knew this had a high wood density to it. And again, we're going for the Cali Cat print right off the bat, and we're going to go by the settings that are on the package. At 200 to 220 degrees C, on the hot end, room to 50 C on the heated bed. So if you think you needed the heated bed, it's suggesting up to 50 C. No speed recommended by the manufacturer. You definitely want to use cooling. I think you need cooling on all filaments. And it says it recommends a 0.5 millimeter nozzle or larger. And of course, we have a 0.5 millimeter hardened nozzle installed on the G-Max 1.5 XT Plus, which never has a problem printing any kinds of filaments whatsoever. So the first print was the Cali Cat, and again, it turned out great. There were no problems with it whatsoever. There is a little bit of high heat on the little corners here, and again on the chin, you can see there's a little bit of curl up there, but it's negligible. I knew I could just dial the heat down, but I was starting at 200 degrees, 202 with the variable from the G-Max. So I'm at the bottom end of the recommended temperature. I don't want to go any lower because I think I'm going to probably it'll interfere with the layer adhesion of each of the layers by lowering the temperature from the recommended settings that came on the package. So I left them at 200 C. I thought that was okay for the next few prints. So with the way this turned out, I was really happy. I knew the wood PLA I had printed with before was never a problem, and I knew this wasn't going to be an issue either. And like I said, the surface finish and the quality and the printability was super easy for this particular wood PLA on the Cali Cat. So I went ahead and moved forward with the rose twist vase, which is always the next print that I do. And this turned out spectacular. Of course, we're in vase mode here, 40 millimeters per second, 2 bottom layers, and a 0.24 millimeter layer height. And it printed out amazing. I really like the surface finish. While this filament is printing, the smell of wood burning, like a wood burning kit from the 70s, is a very strong odor, but it does go away in time. It's not going to linger, but it smells really good. It's a really cool smell. You really know the filament's printing. I did hear a few pops, so I know there's probably a few air bubbles, but that's going to happen with 25 to 30% wood fill, considering wood fill is basically cellulose, which has little air bubbles in it, and if you have a large amount of those, you have an air bubble. So I did hear a few pops, so that might be an issue, but that could be the temperature too. Again, we did have a high temperature issue on the chin on the Cali Cat, so I knew that this could be a variable involved with that popping noise. But actually, the print turned out really good. It feels really durable. There were no problems whatsoever. I love the surface finish. You can definitely tell this is a wood fill filament. It has that kind of look to it, and it definitely has that surface finish that feels like you could sand it and possibly stain it. So the next model I printed, since this seemed to be a more artistic filament, was this cool little owl planter, and I printed these before. I've got quite a few of these laying around the house. But I slowed this down to 35 millimeters per second. I went with a 0.16 millimeter layer height, and I also did 3 top layers, 3 bottom layers, 3 perimeters, and 25% infill on this. I wanted a stronger piece, and it turned out awesome. All the detail is there. There were no problems whatsoever. I did notice there's a little bit of a skip line in one area, right where the chin of the owl is and where the wings are. I think that was probably just a blob of filament that may have caused a slight jam. Again, we're talking about wood fill, which could cause jams at any moment because of that wood fill. If it's not consistently spread throughout the filament, you could get a blob of it, and obviously that would burn in your hot end and could cause a jam. So that could have been it, but overall, I think it printed out awesome. This is a quick print too. It didn't take less than an hour to print one of these. So I knew with the print settings that I had dialed in from the previous models that this print was going to turn out okay, and it did. I really like the way this wood fill looks. I do have a little bit of it left. Not that much, not enough to print any more significant test models because I used up quite a lot of filament on this guy at the smaller layer height and on the Cali Cat and of course the Vase. But I have enough here to print one more small model, but I'm going to save this because I want to print something else with it. I think this is some really great filament. I'm definitely going to order some more of this. This is the kind of filament I've been looking for to do testing with printing out wood items and actually sanding and finishing them with stain and actually making them look more like a wood turned item from a lathe or something similar to that than a 3D printed item. So this is a really good candidate for that. And again, super easy printability. It did run a little hot at 220. I suppose I could back it down a little bit, increase the cooling, play with it a little bit there to really get this dialed in perfectly. But I think the results from the Cali Cat, again, from the rose twist vase and the little owl planter gave me enough indication that this was easy to print with. The finish was exactly what I was looking for or expecting from a wood fill filament. And it was super, like I said, super easy to print with. So I really highly recommend this filament a lot. This was an excellent addition to the MakerBox selection for this month. And if you're looking for a wood fill filament, definitely check it out. Again, links for all these filament brands plus the MakerBox are down in the description. So we've printed with diamond, we've printed with glass, and we've printed with wood. So the next filament we needed to print with was the architectural clay. And I actually wanted to print with this one first, but I'm kind of glad I waited to the end. This did give me a little bit of difficulty printing, not as much difficulty as I had with the nylon, which we'll talk about last, but it was just getting started with this, with the settings, because this is a high temperature printing filament. Now, I'm being very careful with these as I dump them out, because I want you to see all the little prints and the problems that I had. The biggest issue I had was bed adhesion. Now, the first thing I did was I removed the heated bed from the G-Max and I put the acrylic back on because I trust the sanded acrylic. I put a lot of faith in that sanded acrylic because it's always done me well. It's always given me successful prints, and I've never had some bed adhesion issues until I started testing other kinds of filaments with additives in them. And that's where I saw some bed adhesion issues. But again, I went back to the sanded acrylic. I couldn't get the prints to stay on the bed. They started to warp up. Now let's talk about the filament before we go any further. This filament is mixed with a clay powder for prints with an excellent surface finish. And the hot end temperature is 220 to 240, which is the high end. I believe this is a PLA base. That's hot for PLA. And a bed temperature of 85 to 115 C, and a print speed of 60 to 70 millimeters per second. Now that's all the information. It doesn't say you need a hardened nozzle or suggest a nozzle size for this. Just some basic information. This is from Treed. They have a full selection of different kinds of clay type of filaments and wood filaments, metal fills, Peak, some filaments I've never heard of before. But this particular filament, included with the MakerBox this month, has some basic settings that are in the high-end range of printing with a PLA base. I'm assuming this is PLA. It doesn't say here. I didn't look online. So from the information here, we started with 220 C on the sanded acrylic bed. And right off the bat, I wasn't using the heated bed because I trust in that sanded acrylic. And of course, they didn't stick. They warped and came right off the print bed pretty quickly. I didn't get past more than a few layers before they were stuck to the hot end. So after 2 or 3 tries of that, because I'm a glutton for punishment, I went ahead and pulled the acrylic back off again, and we installed the glass bed with the heat and the build tech. So we went ahead and started with, still at 220 degrees C on the hot end, at 85 on the heated bed for the G-Max. All the same settings, except for now I slowed it down. I was printing at 40 millimeters per second. I was seeing some bed adhesion problems, so I dropped it down to 35 millimeters per second. So the first print that came out, while it printed out successful, I have quite a few of them here that have fallen apart, I was seeing something I'd never seen before. Now, I don't know if you'll be able to see it on this one. You'll be able to see it on this one. It's interlayer warping. And I've never seen that before on any 3D prints before, where there's interlayer warping. I hope you guys can see that. I'd never seen it. And it was brittle when it came off the print bed. It literally broke in my hand. So I knew that 220 and 85, my starting temperatures, were going to be too low. There was a strong indication that this needed high heat. So I amped up the heat up on the hot end to 230 degrees C, and I increased the bed temperature up to 95 C. And on the next print, it did print successfully. It did stay on the print bed. But again, we had that and it's hard to see, this one fell apart again in my hands. But we had the interlayer warping again, which again, I've never seen before. So when I pulled it off the print bed, it was intact. And then when I went to kind of play with it, it just started to fall apart. And it's very brittle. It's got just a characteristic I've never seen before with filament. Ooh, that was really sharp. Cut myself right on camera? No, I did not. So to me, we're moving past the comfort zone for PLA. We're now at 200 or 230 C and 95 on the bed. So the next step was to go hotter. So we went to 240 C on the hot end and 105 C on the bed. And I was able to get out a successful print. There was no interlayer warping. I did hear a few pops during the print, which indicated there might be some air bubbles. But again, when you put additives in any kind of plastic for heated extrusion, there is the fear that you could add air bubbles or create air bubbles along the line. But I didn't see any super big ones. There was a few small ones in the surface finish. But again, it printed perfectly, and there was no interlayer warping going on. So 240 C on the hot end for a PLA-based material, and 105 C on the bed, which is super hot in my opinion for printing it. But this is a unique material, and I'm willing to make exceptions. So once the Cali Cat was done, which printed out quite perfectly for such a high temperature, I moved on to the rose twist vase. Now, as you can see, these are all the models I had to show you. The rose twist vase turned out perfect. Now, we did a 0.24 millimeter layer height with 2 bottom layers at back up to 40 millimeters per second, and half speed on the first layer just to make sure we had bed adhesion, and of course using Build Tack and Magic Glue. This print turned out amazing. It looks really, really good. I only heard maybe half a dozen pops during the entire print. Small, very low audible pops. And I believe those are air bubbles in the filament itself because of the additive of the clay powder. But the print looks really, really good. I believe what's happening here, and I may be wrong on here on the scientific analyzation of this printing, is we're actually kiln firing this type of filament as we print it. With the powder that's added and the temperature of the bed and the hot end, it's kind of almost like you're putting this through the kiln as you're printing it. Now maybe we could take this and add a glaze to it and put it into an actual kiln, but I think the amount of plastic that's in here already, this would just disintegrate. So it's really unique. Going past all that speculation of what happens during the printing, is a really unique filament. I really like printing with it. It did take a little effort, and it's running a lot hotter than I really like to print any kind of filament on my G-Max 1.5 XT Plus at 240C on the hot end and 105C on the bed. So I do have some left. I'm going to print some more stuff with it, but this type of filament I think is like a niche filament. It's the type of filament you might use if you're, say, an artist. This could be something you could make digital pottery with. You could do a digital sculpture, print it out in this filament in the different types because they carry different colors, terracotta, white, gray, and I think they have like a tan color as well, and show a client what it's going to look like, print out a larger model, make a solid mold, and do slip casting from your digital sculpting and do digital pottery. I don't know if that exists. Maybe I just coined a phrase. But I think that's where this would be very useful to, is an artist doing, say, architectural models for an architectural company, and they're designing a bunch of custom vases for this build, and they want to see what they look like in the different kinds of pottery. This is the type of filament you would probably use. Other than that, I don't know where else to take this. I don't know if we should try and kiln fire it, put some glaze on it. I would definitely need some more than what we have here, but it's a unique filament. I loved printing with it once it started to print, but my only issue is that heat. Running filament that hot, especially maybe if this is a PLA-based filament, that's a little bit hot, 240C. And having to use the heated bed to actually keep the model from not doing interlayer warping is something I've never seen before. But those are the suggested settings on the package. So it's not like I'm using parameters that aren't suggested. So this type of filament, I would probably suggest you would have to dedicate a printer to this. Something with a chamber so you could keep consistent heat within it, and a special setup on the bed and on the hot end that would be able to handle high heat. Some of these new printers out there are basically like ovens, the metal printers, and I think this would do really well with that type of printer, or like I said, a printer with a heated enclosure and that type. But overall, this was really fun to print with, don't get me wrong. I think this is some cool filament. It was a great addition to this month's MakerBox. It was really cool to print with. It was really easy to print with once I got the right temperature settings and everything, and the print quality looks really, really cool. I definitely would buy a full roll of this and do some further testing, and I probably will. But I want to do some more research into what we can do with the filament once it's printed and what its capabilities are. So definitely a really cool addition to the MakerBox. I highly recommend it, and it was really cool to print with. Again, with those hot temperatures, I'm a little leery, but that could just be the settings required for this filament to actually produce quality prints. So architectural clay filament, really cool stuff. Again, this is from Tree Company. They also have a full line of filaments in different kinds of materials, different additives to materials. That information's down in the bottom in the description. Definitely check them out along with the link to the MakerBox subscription service. The last filament we tested was the nylon, and printing with the nylon proved to be quite challenging. Now let me dump out the models that we printed here, and I'll talk a little bit about this. This was a little bit difficult to print with, even though it boasts that it's the easy to print with nylon. So let's talk about what it says on the bag, and then I'll talk about the difficulties I had printing with this. So it basically, the specifics for, or the parameters for printing are 228 to 235C on the hot end. That is a very specific temperature. The bed temperature, it says room temp, and it says speed not listed, fans no, and other, it says print on glue stick or the enclosed Gecko-Tech sample. Now, I wasn't able to print on the Gecko-Tech sample because I started to run low on filament, and I didn't want to stick this to my bed because I'd already stuck the build tack to the print bed during this process of printing all the other filaments, and when I tried to tape it down, it just popped right off because build tech was like, no thanks. So I need a larger sample of this to really test it properly. Sorry I didn't use it in any of the testing or use it in the testing or the review of this particular MakerBox, but I've heard a lot about Gecko-Tech, and we're going to do a full review. So moving on with the nylon filament, I didn't use the Gecko-Tech. So I had the first print that I tried was going to be on the sanded acrylic, because this says that this nylon blend prints at low temperatures, does not require a heated bed or an all-metal hot end. Use the sample of Gecko-Tech for this month for easy nylon adhesion to the bed. And it says this filament should be printable on all printers. But it had a very specific temperature. So I removed the glass bed with the heated apparatus connected to it off, and I put my acrylic on to print the first Cali Cat. So the first Cali Cat printed out, and that would be this one, on the sanded acrylic, because it says it doesn't need any special print surfaces. It printed out for a little while, and then it popped off the print bed because it was warping badly. And that is at 228 degrees C on the hot end with a cold bed, 40 millimeters per second, 3 top layers, 3 bottom layers, 3 perimeters, 20% infill, and not using anything, glue stick or anything, just sanded acrylic, and it did not stick. It warped immediately, stuck to the hot end, and you get that kind of hot mess. So I knew right away it wasn't going to work with the sanded acrylic. There's no chance. This kind of warpage at that specific temperature meant that if I went lower, it was more likely going to stick, but I'm not going to get good layer adhesion. Why risk it? So first thing I did was remove that acrylic bed and put on the glass bed, which has my Build Tack on it, which, like I said earlier, I've been using the Build Tack Magigoo combination to get all my prints to stick. So I knew, having that experience with these 4 types of materials, having a lot of success with the Magigoo Build Tack combination with or without heat, I would have some easy printability for the rest of my testing, but that proved me wrong. So the next one, the next Cali Cat, because we need to get at least one successful Cali Cat, or I will say I don't want to touch this filament anymore. It printed out all the way up to the top of the head, and when it started the top layers, it stuck to the extruder, and I noticed when I pulled it off that it was warped like crazy, just like the first one that was printed on the sanded acrylic. So what do? Magigoo and heat. Okay, so I also turned the temperature, or the cooling fan from my usual multiple step up to 40% down to 0, because it did say that, and that might have been my mistake. I did get some good bed adhesion at 238 degrees on the hot end with the heated bed at 50 degrees C to start, turn off the heated bed after about 5 or 6 layers, and just let the residual heat seep through the model. It printed. We were able to get a successful print. It printed out in one piece. There it is. But there was no layer adhesion. When I pulled it off the print bed, the head came right off immediately in my fingers, and then I just barely touched the tail piece and it broke right off. And I did notice that there was still a little bit of warping on the bottom, but it wasn't bad. So I decided to go ahead and use a raft, because that helps with bed adhesion. And we had a successful print all the way to the end. Now, I did increase the temperature up to 235 C, no cooling whatsoever, 40 millimeters per second with the first layer at half speed, so 20 millimeters per second, 3 top layers, 3 bottom layers, 3 perimeters, and 25% infill on this particular model. Now, the raft printed out perfectly, but it started to warp about 3/4 of the way through the print, so I thought for sure it would pop off, but it didn't. But the bottom of the model still had some warping on it. It actually warped on top of the raft, and when I pulled this off, the raft and the model came apart perfectly, so I knew my raft settings were right on. But this model turned out good, but I had to increase the temperature to get there, and the warping was happening. I was having to add Magigoo Build Tack heated to a slow gradual room temperature cool and the high end of the temperature setting just to get a successful Cali Cat to print. Now, it feels like this is a lot more durable. Yeah, I'm not going to be able to break that easily. So the high end temperature with all those other parameters, not as easy to print with. But we got a successful print. So I moved on to the rose twist vase. Now I'm down to maybe 15, maybe less than 20 grams of material left. So I knew I couldn't print any functional parts to show you guys, but I had to at least get a rose twist vase out, because this is a single perimeter and it'll demonstrate layer adhesion and the quality of the print and surface quality. And we'll find out, since I did have this laying out in the garage or in the shop here for more than 24 hours, not in a bag with a desiccant, it was just open air, if it grabbed any moisture. I mean, I live in Las Vegas and there's not a lot of humidity here, but there's enough. So, and nylon will suck it right up, all that moisture. But this printed out perfectly. I did hear a few pops and I did see one puff of steam, but that may have been from the moisture of my fingers handling the filament. That may have not have been just moisture in general.
from my understanding, when nylon absorbs moisture, it doesn't absorb it in one single spot. It's going to absorb it throughout, and you're just going to get a steady flow of steam and pop out of the nozzle if it absorbs too much. But this didn't have that many, and it feels pretty good. It's very flexible. It feels pretty strong. I don't feel any layer adhesion issues. So running at the high end temperatures with the slowly, gradually cooling heated bed from between 30 and 50 C, it actually got this nylon to print. But it wasn't easy to print with, and it wasn't for any printer. It is for printers that are used to printing with nylon. I think with a heated build chamber, this would have turned out even better. I would have had more success with the models. I think it requires a lot of residual heat to be in the air. Touching the models after they were done printing, they were super hot. Like the hot end had transferred heat throughout the entire model. So that was a problem for me. I knew right away that this is the kind of nylon I probably would not print with on my G-Max because I don't have the right parameters to get it to print properly. And it isn't as easy to print with as it says on here. I did have to do basically the same kind of settings I would for any nylon that I printed with in the past. So overall, I think the print quality is pretty good, but you do have to do your typical nylon settings. Now that may have just been me, it may be my G-Max printer, but in my opinion, it wasn't easy to print with. When I did finally get some successful prints, the print quality is great, but I've already used up all the filament from the sample, so I can't really print out anything else to show you guys. So I don't know how well it would print in a functional part, and that's probably what I would use this for, say like a base plate for a skateboard or something that requires some rigidity and yet flexible at the same time. Maybe even print a full enable hand in this type of material. I think that would be pretty cool. It would have to be different colors, obviously. But I would want to know that it would be strong enough and I wouldn't have to worry about adding a bunch of parameters to get me to regular nylon printing, because then I would just buy regular nylon and print it that way. So overall, I think this is some cool filament. It was a little difficult to print with. The print quality is really cool. Surface finish is really nice. But in my testing, it's not as advertised, not as easy to print with. And I definitely would require more of it, and of course a heated build chamber to make sure that this stuff printed out properly. Okay, so we've gone over all the filaments that came in this month's MakerBox. We've printed out all kinds of cool stuff. We had some issues, we've had some success, we've had some really great looking models, and we've had some models that weren't so great looking. But overall, as far as a selection of filaments to get in a subscription box, this was a lot of fun. Again, I felt like a mad scientist working on this because every filament required a new set of parameters, a new build surface to print on. It wasn't always the same every time, and that's really cool. Plus, it gave me a chance to try out some filaments I have never seen before. Some of them may be experimental, like the PLA diamond. Others I've used before in other situations, like the wood fill, and I've used nylon in the past. But a glass-filled PLA and this architectural clay, these are filaments I've never heard of before, and they were a lot of fun to print with. Overall, this was a really cool selection of filaments in this month's MakerBox. Plus all the other goodies. We've got the Gecko Tech sample, we've got coupon codes, we did get a nice little bag of candy, which I did eat, and we've got a cool MakerBox button, which I will add to my collection of buttons going on my jacket. So even though I had to use Magigoo and BuildTech for a lot of the prints, everything else, I think the settings that were printed on the bags, as far as like the recommended settings for these print temperatures for these filaments, was pretty spot on. We did have to adjust them slightly, but that comes with testing filaments. Again, I don't print temperature towers or retraction tests or that. I have a model, the Cali Cat, that has a lot of those features built into the model, which makes it easy for me to see a lot of that stuff on a single print and see the print quality of the surface, or the surface quality and the print quality in fine detail, because that model has that as well. So for me, what I printed, those showed a really good example of all these filaments. I was able to get a good idea of if I would want to buy these filaments in the future, which from all these filaments, I think I would buy pretty much every one of them, with exception to the PLA diamond. I think that needs a special printer for it. And again, this nylon I think is maybe not so much as advertised. I did get it to print, but it took some special settings. The wood fill PLA, I can't wait to get some more of this and do some really cool projects with it. The architectural clay, digital sculpting sounds like, or digital pottery sounds like a new thing, and I may even dabble a little bit in that too. That sounds like fun. And of course, the glass-filled PLA, which I think I'm going to use for parts for a 3D printer. So this gave me a sample of filaments that I would probably go out and buy a whole roll of, and maybe depending on my success or failure, I may not like those filaments and I feel like I may have wasted money. But having the MakerBox monthly subscription service send me 5 filaments that I've been wanting to play with, even though I didn't know what they were until I got here, That's awesome. I highly recommend the MakerBox monthly subscription box. I know there's a lot of subscription boxes out there, but to get this selection of filament with a few extras and have this much fun 3D printing again, because I learned more printing from these 5 filaments than I've learned in printing so far in my adventures in 3D printing, if you say. They taught me a lot about different settings, what can be printed, what can't be printed with different kinds of print surfaces. This was a really fun experience, and I'm really grateful that MakerBox sent over this for us to review and test on the channel. Huge shout out to them. If you want their information, it's down in the description, along with links to all these manufacturers, along with the models that we printed so you can print them yourself. And a huge shout out to Shea Street for putting together the care packages for everybody who wasn't able to attend a Maker Fair this year. And MakerBox was kind enough to donate boxes to that effort of his, and this is where that came from. So huge shout out to Shea for doing that. And I really enjoyed printing with the MakerBox. I'm definitely going to consider subscribing to this because this type of filament coming in the mail was a cool surprise. And like I said, I had a lot of fun. I learned a lot, and I have some really cool prints to share with you guys and some settings and some experiences. So if you're considering buying any one of these 5 filaments, you can refer to my video and see the experience that I had. Of course, your settings may vary. Always do proper testing before you print with any filaments like I did. And having a few samples like this, you might want to consider subscribing to the MakerBox subscription service. Well, that about wraps it up for this video. I hope you guys found this episode interesting and informative. And if you're looking for ways to support the channel, check out those affiliate links down in the description. And of course, don't forget to subscribe to the channel, comment, like, and share those videos, and I'll talk to you guys soon.